This is the electronics board and all the wiring for the pumps and the connections to the PV panel and the battery and the 6-position monitor. All these connections go through the electronics board. So let's take a quick look at the electronics board to see how everything is connected and works. The first thing you want to look at is towards the center of the board, and this is where the power comes in to the electronics board. You'll notice on the left-hand side you'll see something that says PV. That's for the photovoltaic panel. So the photovoltaic terminals are connected right here. Notice there's a plus sign and a minus sign. So the positive terminal for the photovoltaic panel is the red wire, and that's connected here. And the positive terminal for the battery terminal is connected on this side. And both these cables are labeled, so you shouldn't have a problem connecting them if you need to connect them. Okay, so we know where the power comes in, and we can turn that power on or off with these switches. If we want to connect the battery, we can press this switch up. If we want to connect the PV panel, we'll press this switch up. If we want to, or if we want to connect them both, we'll turn them both up. Okay, so you notice there's nothing on this monitor right now. This monitor is used to monitor the power, whether it's coming from the photovoltaic panel or the battery or the charge control, the battery charger or whatever. This will tell us the voltage that's available to us. So if we push this up, we can see that the voltage available to us right now is 12.96 volts. All right, that's plenty. Now, all right, so we know where the power comes in. We know how we can monitor the voltage. The next thing we want to take a look at is the 6-position monitor. This will tell us the temperatures in the various locations on the test fixture. For example, if we want to look at the temperature on tank number 1, we'll turn this dial to position number 1 right here. Might be a little off, but that's number 1, and the temperature is 51.4 degrees. If we want to see the temperature on tank number 2 right now, it's 49.1 degrees. If we want to take a look at the ambient temperature, that's position number 3. So the ambient temperature is 50.1. Now notice all these temperatures are just about the same right now because we're not outside, we're not collecting heat or anything. All the temperatures should be just about the same temperature. All right, that's 3 is the ambient temperature. 4 gives us an indication of the intensity of light that's striking this sensor right here. Okay, so if we multiply this reading by 2, that'll give us the approximate intensity of sunlight in BTUs per square foot. Okay, now this isn't exactly right, and it's more accurate at higher intensities of light, but this will give you some indication of how much sunlight is available. All right, so that's position number 4. Position number 5 tells you the temperature on collector number 1. That's the serpentine collector. And position number 6 tells you the temperature inside the modified trickle-down collector. Okay, so now we know how the power is connected, how we can monitor the power. We know how to look at all the different temperatures, and we can get an estimate of the light intensity. Now the last but not least thing we want to take a look at are the controllers. Okay, now we know that the way the controller works, if the temperature of the collector is higher than the temperature of the storage tank, the the controller turns the pump on. Now, this controller here is used to control the pump that goes to collector number 1. This is controller number 1. Now, if we set the differential to below the threshold that it takes to turn the pump on, we can turn the pump on. And this controller has a very high range. So just by turning this dial totally counterclockwise, we should be able to turn the pump on. See, when that green light comes on, that means that the pump is on. Now this red LED indicates the amount of heat available. Well, right now there's no heat available, but we've been able to turn the pump on. Okay, and that's not a good thing. So normally the best setting for this controller is about 2 o'clock. That's right about here. Okay, now let's take a look at this controller. This is another basic controller. It's a little different. It has a mechanical relay, so it takes a higher voltage to operate the relay. And also the range is not as great. Now if I turn this differential adjustment totally counterclockwise, that's the least possible differential that we'll have to turn the pump on, but that's still not enough to turn the pump on, and that's good. This setting here represents a temperature differential of about 5 degrees to turn the pump on, and that's about as low as you want to go anyway. But suppose we want to do a test and we want to force the pump to come on. Well, since this controller is regulated by thermistors, which change resistance as the temperature changes. In other words, the resistance becomes lower as the temperature gets lower. We can force this controller to turn the pump on by lowering the resistance on the collector. Or if we raise the temperature on the collector, the resistance of the thermistor will go down. But we can force that to happen by hooking another thermistor. This is another thermistor, and we're going to connect that in parallel with the thermistor on the serpentine collector. And you see these two terminals. We're going to just connect them and see if we can get the pump to come on. You got to get them on the terminals if you want them to work. There you go. All right, so I've turned the pump on. You can see the green light that just came on. That indicates that the pump for the modified trickle-down collector is on. But notice the red light is not on. That means there's really no heat available for collection. We just did this to test our pump. We can also do this to check the flow rate of the pump because we're going to have to turn this on later. So you can use either a thermistor or you can just short these two terminals out, and that will connect a 5-volt supply to the center terminal. Anything higher than 2.5 volts should be sufficient to turn them on.
Of it, so make it last. Time is intangible. It isn't something that you can grasp. Look at everyone around me keeping track of time. Everybody's worried for me, but I'm doing fine. I'm doing what I want and I'm where you make of it, so make it last. Time isn't everything, it's what you make of it, so make it last.